So a couple things about this question. This is on page 473, and it starts off saying, suppose secant of theta is equal to 4. So this year, we've learned the reciprocal trig functions. We've learned secant, cosecant, and cotangent. And each of them is related to one of the functions that we know. So for example, since secant theta is related to cos, and this is what we know, what we can do is we can always write out the other one if we know the first one. So for example, if I know secant of theta is equal to 4, morning, if I know that secant of theta is equal to 4, then I can write cos of theta, and because they're reciprocals of each other, then their answer will be reciprocals of each other. And we're going to use this shortcut a fair bit. I mean, technically, and I don't, you can write this down if you want. This is the shortcut. If I know that secant of theta is equal to 4, then the answer will be the reciprocal for cos. If I wanted to do this the long way, first of all, I would have to do this. Well, secant of theta is equal to 1 over cos of theta, so I would be able to change this to that. And then I would do algebra to get cos by itself. So since cos is on the bottom, I would have to multiply both sides by cos theta. And then if I wanted to get cos theta by itself, I would have to divide both sides by 4, and I would get cos of theta is 1 over 4. So since secant and cos are related, instead of doing this work in green every time, because they're reciprocals, the shortcut would mean that their value will be the reciprocal. So if I know secant of theta is 4, which is 4 over 1, then I can write cos of theta to be 1 over 4. And that's the exact same equation, but the nice thing about cos of theta equaling 1 over 4 is now we have changed this into a grade 11 trig question that you've done before. Okay? How do you solve for theta if you have cos of theta equals 1 over 4? A little review of grade 11. So in grade 11, you would have thought about your CAS rule. And notice, since cos is a positive ratio, it can't be in 2 and 3. It would have to either be in quadrant 1 or quadrant 4.
Hi, so sorry to interrupt.
No problem.
I have Anton to the office, but when it's convenient for the both of you.
Okay, sounds good, thank you. They want you to come down to the office once we're done with the session, so you can watch the example first. Okay, so if you know this, it's either in quadrant 1 or quadrant 4, then you can imagine an angle in quadrant 1, right, with its reference angle label. Now in quadrant 1, the reference angle is the same as the angle. And you can imagine an angle in quadrant 4 with its reference angle label. And since cos is adjacent over hypotenuse, you would know that this side is 1 and this side is 4, this side is 1 and this side is 4. And you could label those parts of your triangle. Now, if you went back to grade 10 trigonometry, can you see that you could figure out your reference angle? Because figuring out your reference angle is based on the actual triangle. My reference angle is that cos of my reference angle is also going to be 1 over 4, because I've drawn my reference angle in those triangles. And if I want to find my reference angle, what did you have to type in your calculator from grade 10 and 11? Cos inverse, right? We would type into our calculator cos inverse of 1 over 4, and we would find our reference angle to be 75.5 degrees. Does it say to the nearest degree? Oh, we're not, I'm on, oh my goodness. I'm reading B already. We're not even solving it, but we'll write it down, 75.5 degrees. So we've got our reference angle. Now, again, a good thing to always do is read questions as you're going along, because you might find out read a question and start thinking about the mathematics and solving something that you know, but you might not be solving exactly what the question is saying. What we're doing right now is we're solving part B. So let's just do B first, because it says determine the exact values of the other trig ratios. We'll do that afterwards. Okay? So now we've got secant as 1 over cos. We want to find the angle to the nearest degree. And what we've done so far is we took secant and changed it to cos, used our cast rule to draw where the angle would be. And now we have our reference angle. The question asked us to solve over the following domain from negative 360 degrees to 360 degrees. So we have to understand, what does this domain mean? This domain, oh, and it said theta, sorry. Theta. This domain, well, does it make sense that once around the circle is 0 to 360 in the positive direction? And once around the circle in the negative direction would be from 0 to negative 360 degrees. So when I'm thinking about domain with trigonometry and angles, I like to think about my positive angles and my negative angles separately. So even though I have negative 360 to 360, when I'm thinking about it, for the positive ones, 0 to 360, my negative ones would be 0 degrees to negative 360. So I'm sort of breaking up the negative 360 to 360 by thinking about the positive angles and the negative angles separately. I'm going to draw the positive angles on my diagrams in green. Does it make sense that this would be one positive angle and this would be the other positive angle if I was going once around the circle? If I want to write those answers out, the one in quadrant 1 is identical to our reference angle. But the one in quadrant 4, if I know that this is 76 degrees, does it make sense that I could figure this one out by doing 360 degrees minus my reference angle of 76 degrees, and what I would have left is that angle. So I go to my calculator again, and I would get 284 degrees. Now in red, if I think about my negative angles, this negative angle would look like this, and this negative angle would look like that. Because we also want to do the negative angles from 0 to negative 360. Now, the one in quadrant 4 is the easiest. Can you see that the one in quadrant 4 is the same as your reference angle, but it will be negative, so that would be negative 76 degrees. And the one in quadrant 1, well, can you see that this angle in quadrant 1 is going to be identical to this angle in quadrant 4? Because if you think about going all the way around, which is 360 degrees, and subtracting your reference angle, whatever answer you get will be the angle, but it will need to be negative. So again, when I'm thinking about figuring out this angle in red, I'm thinking about going 360 degrees is all the way around minus my reference angle. That will leave me with negative 284 degrees. And this is a very typical trig question because it involves your trigonometry from grade 10, grade 11, and now grade 12. So I don't know if you want to put a star beside 3B. You will get lots of questions. Chances are your final exam will have a question like this on it. This is a very important kind of question. And it is really requires a lot of understanding for previous years. You have to understand how reference angles work. Then you have to understand how to solve equations for angles. Now, part A says determine the other trig ratios for 0 to 180. So we'll do that. If they're talking about 0 degrees to 180 degrees, it would only be in quadrant 1. We know the hypotenuse is 4 and the adjacent side is 1. Again, to find the other ones, we're going to need the opposite side. And you're going to get really good at a squared plus b squared equals c squared. In this case, c squared is 16, minus 1 squared would be 15. This side will be the square root of 15. And once we have that, we can find the other ones we don't know. We can write sine of theta, and we can write tan of theta. We can write cosecant of theta, and cotangent of theta. So sine of theta, opposite over hypotenuse. Tan of theta, opposite over adjacent. Cosecant then would be just the reciprocal. Same thing, cotangent will be the reciprocal of tangent. So please circle 9, 10, and 11.